Hello friends, welcome to Shiksharthi. In this session, we shall be discussing inequalities involving modulus. So let's start. Now in the very first place, we should know what an inequality is. That is a prerequisite for this session. Second, we should know modulus as a function. Now when I say we should know modulus as a function, that means we should at least know the domain, range and the graph of modulus. Okay. The modulus inequality, the starting point for an inequality would be the equality part, and then when I say inequality, inequality means not equal to. So we will start off with an example which says modulus x is equal to 2. So now when we say this, what do we mean by this is, if modulus x is equal to a 2, in that case, what is or are the values of x? In order to understand this better, let us make this into two functions. Though we know that this is an equation, but we are going to convert this into two different functions. So how do we convert this into two different functions? One is we identify the left hand side of the equality, and then we identify the right hand side of this inequality, and then equate it as two different functions. Meaning thereby, one side we are saying y is equal to modulus x, and on the other hand we are saying y is equal to 2. This is the very first thing that you are expected to do. Convert the left hand side as one of the function and convert the right hand side of the equation as another function. If you have a combination of functions on one side and on the other side, then you may choose this judiciously. Okay. Second thing is plot their graphs. Now when I say plot their graphs, what I mean to say is graphs of both. And then find out the point of intersection. Find common solutions, which are nothing but the point of intersections. Find common solutions is the third thing that you're expected to do. So okay, now when I have to plot the graph of modulus of x, we know the graph of modulus of x, which is V for victory. So I am plotting the graph of modulus x with the color which is red in color. Then the other graph that we are going to plot here is the graph of y is equal to 2. So this is y is equal to 2 and y is equal to modulus x we have already plotted. Once you have done this, then let us identify the points of intersection. So this is one point of intersection, this is another point of intersection, and find out the value of x here. So this will be plus 2, this will be minus 2. Okay, once you have done this, then what are the values of x? X is equal to minus 2 or plus 2. This is the solution set that we get eventually. Now let us use the same logic to solve the inequalities involving modulus. Okay, so now what we will do here is we will target this with the help of graph. So we know that we are supposed to make the graph of modulus x. The other graph that you are expected to make here is the graph of y is equal to 2. The third thing which you need to note here is, now you will see that there is no equality in between, there is an inequality which says that modulus x is less than 2. Now when we are saying less than 2, that means we are talking about modulus x minus 2 being less than 0. Or in other sense, we are talking about, let us say, if we would have assumed that this modulus x is equal to a y, then we are basically talking about the line y less than 2. So let me shade the region. So you will see that we have taken the constant function on one side, which is 2, and the function involving variables is taken on the other side, which is modulus of x. And now what we are suggesting here is try and convert this entire discussion into y is less than 2. Given the fact that we already know that this line is y is equal to 2, now we are talking about the region below this and above the x-axis, below this line and above the x-axis. I hope you would understand why am I using an arrow. The arrow means that the point next to it is not included, is what we are talking about. So plotting this on another graph, now once I know that this is the graph of modulus x, okay, we know this is the graph of modulus x, and this is the line y is equal to 2, which is the dotted line that I am drawing now, and we are talking about all the values below this. The values below this. Okay, now when we are talking about values below this, then the point which needs to be understood here is it is below this but above or on. So for that we should put a dot sign here, not an arrow. I'm talking about the x-axis part. Right? So now let me plot this on the x-axis. So this comes out to be minus 2. This is plus 2. And we are talking about now the line which is, we are talking about all the values of x which are lying below this. So the point to be understood finally is, are we talking about x greater than minus 2? And less than plus 2? Are we talking about all such values of x? Yes. Because this is ideally the region that we are talking about. Right? So from here you can have a takeaway. The takeaway is, whenever modulus x is less than a positive number, then x will lie between the negative and the positive of that real number. This is the takeaway that you can have from here. Now using the same logic and now solving the inequality modulus x is greater than and equal to 2. So in that case, once we have drawn the graph of modulus of x, which is this, and at the same time we have drawn the line y is equal to 2. Now the next thing that we need to do here is maybe plot these values of x, which is +2 and -2 accordingly. And then we are talking about the region. So if I assume this as y, which is what was suggested, so in that case the inequality gets converted into y is greater than or equal to 2. So we are basically talking about this point inclusive, and from here till the above point is unbound. So you will see that modulus x is greater than 2 and equal to 2 eventually gets converted into an unbound inequality, and modulus x is less than 2 becomes bound because of the range of modulus x. It becomes bound, and the binding factor here is, we know that the range of modulus x is greater than or equal to 0, so that binds. But when I talk about the inequality modulus x is greater than or equal to 2, it is a kind of an inequality which is unbound. And since it is unbound, now just we need to check the area that we can shade here. So do we shade this area, or do we say that, let me extend this line, and then eventually we are shading this area. The area that is between the line x is equal to -2 and above the graph of modulus of x on the negative side of x, and on the positive side of x we are talking about the area bound between the line x is equal to +2 and the area above y is equal to +x. So what is the final answer that we get from here? X is less than or equal to -2, or x is greater than or equal to +2. This is the final answer that we get from here. Okay, a quick thing to revise finally, so that we are able to take our learning to the next level. So if I say, if modulus x is less than or equal to a positive real number r, then can I say x will be greater than or equal to -r and less than or equal to +r? This is one thing that we have learned in this session. Next, if I say that if modulus x is greater than or equal to +r, then can we say that x is less than or equal to +r? So should be x is less than or equal to -r. So one side we are saying x is less than or equal to -r, or x is greater than or equal to +r. So if x is greater than, if modulus x is greater than or equal to +r, then we can say that x is less than or equal to -r, or x is greater than or equal to +r. Hope you were able to learn something from this session.